Okay, this is the first of many problems this semester we'll see where using trig is not a bad way to go. So let's look at the problem. The problem says a trough for holding water is formed by taking a piece of sheet metal 60 centimeters wide and folding the 20 centimeters up on either end up as shown below. You don't have to just make troughs this way. I've seen people make gutters this way, and the idea is you want it to hold as much water as possible. In this case, we don't know how long the gutter is, so it's really only going to depend on the area of this little trapezoid here. And so what we want is given what we have, how do we find the area of the largest trapezoid from this? Now what I'm going to do is go to my little whiteboard here so we can at least get you started. I don't want to do the whole thing, but here what we want. I want the area. Now we can use the formula for the area of a trapezoid. It's usually easier to figure out where it came from than the area of a trapezoid. Really all they did, right, is they went like that, and they added that triangle plus that rectangle plus that triangle. Now what am I going to get here? I have to call something like this h, because I don't know what it is. That one's 20, which is great. How about if we call this x, and this is still 20? And so the area is going to be, let's see here, 20h. That's not so bad. Plus 1/2 x times h plus 1/2 x times h. Well, that's just xh. And that's not miserable. Now, there's a miserable way of doing this, by the way. Well, considering they want the angle, I don't want to do this without having an angle in it. We could actually just try to use the Pythagorean theorem and get a relationship, and then we're all done, find theta. That's actually a lot messier than what we're going to try. So this is what we're going to do. What I'm going to do is remember that this angle right here is also theta. These are alternate interior angles. If you don't like that, let me put something in here that I'm going to erase in just a second. Yes, if that's theta, right here I have 90 minus theta, and then back over here I'm going to get theta again. So the angle over there really is theta no matter how you think of it. Okay, and the angle over here is also going to be theta, which isn't so bad. The idea is, how can I find x, how can I find h, and then where do I go from there? Well, we're going to use trig. So what I'm going to do is, if that's theta, I know, for example, that the opposite over the hypotenuse is the sine of theta, right? So I'm going to write down that the sine of theta is equal to h over 20. So instead of h, I can write 20 times the sine of theta, like that. Now, here's your mission, right? Do the same for x. Once you know what x is in terms of theta, and once you know what h is in terms of theta, you can get this whole formula in terms of theta, and you're going to get a derivative that's much easier to take than if you had actually done all the Pythagorean theorem stuff. I think they actually tell us that the smallest theta can be is 0. That's a stupid trough. It won't hold any water, right? And the biggest theta you need to consider would be 90 degrees. If you're folding this up at 90 degrees, you're going to get a nice rectangular looking trough. But if theta got bigger, right, you'd actually wind up getting a smaller amount of water. So they tell you that much. So find what a is in terms of theta. Remember, you do have a closed interval when you're all done. And good luck. The solution is on Paul's online notes. But if you're a STEM major, don't you dare look at that. Start working like crazy with each other, and check your answers, and maybe you can actually dredge up the trig from your background that we're going to need to finish this.